अस्सलाम वालेकुम दोस्तों, वेलकम बैक टू माय चैनल। आज हम क्लास 9th मैथमेटिक्स लेक्चर 4 का पार्ट नंबर 2 शुरू करने वाले हैं, जिसमें हम मल्टीप्लिकेटिव इन्वर्स ऑफ ए मैट्रिक्स के बारे में बात करेंगे कि किसी भी मैट्रिक्स के मल्टीप्लिकेटिव इन्वर्स से क्या मुराद होता है। सो बेसिकली फॉर एग्ज़ाम्पल मल्टीप्लिकेटिव इन्वर्स क्या होता है। इफ़ वी हैव अ मैट्रिक्स ए, ओके, अगर फर्ज करें हमारे पास एक मैट्रिक्स ए है, देन इट्स मल्टीप्लिकेटिव इन्वर्स इज रिप्रेजेंटेड बाय द सिंबल ए इन्वर्स, ओके, which is equal to 1 over a determinant into adjoint of a। तो ये बेसिकली मल्टीप्लिकेटिव इन्वर्स ऑफ ए मैट्रिक्स है। इफ़ वी हैव अ मैट्रिक्स ए, देन ए इन्वर्स इस सिंबल के साथ हम उस मैट्रिक्स के इन्वर्स को से रिप्रेजेंट करेंगे, एंड इस फार्मूला इज़ 1 over a determinant into the adjoint of a। अब इस फार्मूला के अंदर हमारे पास 2 टर्म्स आते हैं। लेट्स दिस इज़ आवर इक्वेशन नंबर स्टेरिक। इसी फार्मूला के अंदर अगर आप देखें इन्वर्स की जो फार्मूला है, यहाँ पर एक टर्म है डिटर्मिनेंट ऑफ ए एंड सेकंड है एडजॉइंट ऑफ ए। अब डिटर्मिनेंट और एडजॉइंट ऑफ मैट्रिक्स ए, इसका क्या मतलब बनता है। आइए सबसे पहले हम इसको जानने की कोशिश करते हैं और इसके बाद हम इन्वर्स की प्रैक्टिस करेंगे। तो फर्स्ट करें हमारे पास लेट वी हैव अ मैट्रिक्स ए इक्वल टू 1 2 3 4, okay, and we write it at this point again that a is equal to 1 2 3 and 4, okay. So from these two matrices we will learn about the determinant and adjoint of the matrix A, okay। अब यहाँ पर अगर हम देख लें, आप देख सकते हैं कि फ़र्ज़ करें आपका जो मैट्रिक्स ए है वो 1 2 3 4 के बराबर है। तो इस मैट्रिक्स की डिटर्मिनेंट से क्या मुराद है। डिटर्मिनेंट ऑफ द मैट्रिक्स ए इज़ रिप्रेजेंटेड एज गिवन a determinant, and this is equal to 1 2 3 4, okay, and now the determinant symbol will be applied to the whole matrix। अब यहाँ से हम इस डिटर्मिनेंट की जो वैल्यू होती है वो कैसे फाइंड आउट कर सकते हैं। सो इट इज़ बेसिकली the product of first and last minus product of second and third, यानी a determinant will be equal to, first of all we multiply the first and last term of the matrix, that is 1 into 4। इसका सबसे पहले हम प्रोडक्ट लेंगे, यानी 1 into 4 से हमारे पास आएगा 4, and then we separate the product of second and third term, यानी यहाँ पर जो माइनस का साइन है वो हम अपनी तरफ से लगाएंगे, and then we take the product of second and third term which makes 2 multiplied by 3 as 6। Now from this it is clear that 4 minus 2 is equal to 4 minus 6 is equal to minus 2. So finally the determinant of the matrix A is equal to minus 2. Okay, now from this point it is clear that determinant is not a matrix, it is just a real number. Okay, इससे हमें ये पता चलता है कि डिटर्मिनेंट क्या है. ये बेसिकली एक नंबर होता है. इट इज़ द रिप्रेजेंटेशन ऑफ ए रियल नंबर, not a matrix. Okay, now let's look at this right side. Here A matrix is equal to 1 2 3 4 and we are going to find the adjoint of this matrix. So what is meant by the adjoint of this matrix, which is represented as ADJ, means adjoint of matrix A. So how we can find the adjoint of any matrix A? We can find out the adjoint of any matrix A simply by changing the places of the first and last elements, that is 4 and 1, and then changes the signs of the second and third element. These two element signs will be changed. So this will become as minus 2 and this plus 3 will be converted into minus 3. So finally we got the adjoint of the matrix A. Now you can see we find both the terminologies, adjoint of the matrix and determinant of the matrix. So these two terminologies are very important to find the inverse of any matrix. Basically the inverse of a matrix is the product of the inverse of a determinant. Inverse of determinant is because we write it as 1 over a determinant. Okay, so this is basically the inverse of this determinant. And adjoint of the matrix means product inverse of multiplicative inverse of the matrix is basically the product of adjoint and inverse of the determinant of the matrix. So from these two cases it is clear that the inverse of the matrix A, which is written as A inverse, equal to the product of the inverse of the determinant, that is 1 over minus 2, and then the adjoint, which is 4 minus 2, 3 and 1. And finally when we multiply these two terminologies, it is the case of multiplying a constant into the matrix, which we discussed in the early classes. So the same situation is this, we multiplying this constant minus 1 over 2 to this matrix, and we know about that how it is multiplied. It is just multiplying this term to the every element of this matrix. Okay, so it will basically written as 4 into minus 1 over 2, basically minus 4 divided by 2, minus 2 into 1 over 2 is basically minus 2 divided by minus 2, and then minus 1 over 2 into 3 will be make as 3, minus 3 divided by 2, and then minus 1 over 2 into 1 will make minus 1 over 2. Inverse of the matrix A will be equal to this will be cancel each other, and finally there will be only minus 2 remaining. Similarly these minus 2 and minus 2 will cancel each other, and we have 1. Here we cannot simplify these two terms, 3 and 2, so we will write it as minus 3 divided by 2, and the last one -1 divided by 2 cannot be simplified, so we will write it as -1 over 2, and this is the final answer. So from this whole lecture, what we learn in this lecture that what is the multiplicative inverse of a matrix. So basically, multiplicative inverse of the matrix, if we look at this case here, A is a matrix and the inverse of this matrix is again a matrix, so it is clear that the multiplicative inverse of a matrix is again a matrix. Secondly, we can also see there that what is equal the multiplicative inverse of a matrix. It is basically the product of the inverse of the determinant, because this is the only a determinant, but we write it in the denominator, so it becomes the inverse, multiplicative inverse of the determinant this. So multiplicative inverse of a matrix is finally the product of adjoint of the matrix and inverse, multiplicative inverse of its determinant. Okay, and how we find these two terms, determinant and adjoint of a matrix? Look, in this case this is matrix A, and we find its determinant just by multiplying the first and last terms of the matrix, which makes 4, and then we separate the product of second and third term from the first product, okay, which is 6, and finally we got 4 minus 6 equal to -2. So from this example, from this practice, we got that a determinant is equal to -2, which means that the determinant of a matrix is always a real number, always a constant. It is not a matrix. Secondly, we find the adjoint of the matrix A. Here you can see that A is this 1 2 3 4, and we find the adjoint of matrix A is adj of A, means adjoint of A. And how we find this? We find this adjoint of the matrix A just by changing the places of first and last terms. Okay, this is 4 and 1, and here is 1 and 4, so we change the places of first and last terms, and then we change the signs of the second and third terms. So before taking adjoint, there is +2, and in the adjoint there is -2, there is +3, and there is -3. So basically adjoint can be found simply by changing the places of first and last terms, and changing the signs of the second and third term. And finally, when you find the adjoint as well as the determinant of the matrix, then finally you can find the inverse of the matrix by simply multiplying them. Okay, here we multiplied these two, adjoint and determinant inverse, and then we got the final matrix -2 1 -3 divided by 2 and -1 over 2, which is the final inverse matrix for the matrix A. One thing you should learn that the inverse of a matrix is possible only when the matrix is a square matrix. If a matrix is not a square matrix, then its inverse cannot be found out. Okay, and in another case, the inverse cannot be found if the matrix is a square, and this case is when the determinant of the matrix is 0. I mean when the matrix is a singular matrix. So this is the methodology to find the inverse of a matrix, of a square matrix of order 2 by 2. Whenever you find the inverse of a matrix of order greater than 2 by 2, that is 3 by 3, 4 by 4 matrices, then the methodology will be changed slightly. The formula will be basically the same as 1 over a determinant into the adjoint of A, but the procedure to find the determinant of the matrix and adjoint of the matrix will be changed from these two. Okay, so when we discuss about the inverse of square matrices of 3 by 3 and 4 by 4 orders, then we will discuss it later. But for now, to find the inverse of a square matrix, this is the whole procedure. So I hope you understand this lecture. If you have any question, then you can comment, and we will give you a response. So hope for the best and see you in the next lecture. Thank you for watching.